Okay, let's start chapter 10. Okay, we go into polymer. Okay, we start. Okay, chapter 10. Chapter 10 is a long chapter and also is the last two chapter that appeared in your final 4 question. The last 2 question is choose one. Okay, you got 5 question. Question 1, 2, 3 compulsory. Then question 4 and 5 you choose one. So they are either polymer, ceramic, and composite chapter. Okay. So we will now look at polymer. After we clear polymer, then there's one more slides for ceramic. After ceramic, there's one more chapter, right? So there's one more chapter with electrical and electronic material. This one, I will not ask you. This one, the last chapter, I will not ask you. Okay, so your final will up to here. Okay, up to here, because you look at your LO. 9 chapter. So you see the last LO, you need to know polymer, ceramic, composite, and electrical, electronic characteristics. But for your final, I ask until here. This one, okay? This one, if we have time, then we go. If you have no time, then you just read the PowerPoint slides. Okay. So this one, electrical, electronic material, this one important if you do EE, electronics program, that you need to do about wafer, capacitor, all this. But you guys are mechanical, so just touch and go. This one just a brief information that you aware that the material you're dealing with, they have electrical properties. Until here. Until yes, before electrical, this one. Test 2 is from here. Your test you see mechanical. Test 1 is until mechanical. So test 2 is here until here here. So yeah, I will give you the scope when we come to test 2. Okay, so again, chapter 10 slide, there is a very big chapter, so I break into 2 different slides. Okay. So chapter 10, we'll go for polymer first. Then we go into ceramic. Okay. Just for info, there will be 1 question on polymer, 1 question on ceramic for final exam. Okay. So okay, polymer, you heard about this one during your chemistry class. You learn about the monomer polymer. Okay. So here we involve some calculation on the how you do polymerization and all this. Okay. So again, introduction. The first type of polymer we look at is hydrocarbon polymer. So hydrocarbon means you have C and H that consists of hydrogen and carbon. Right. Now, why hydrocarbon? Hydrocarbon, you deal with hydrocarbon in daily life as a mechanical engineer. You deal with engine. You deal with petrol. You deal with fuel. All this. You deal with plastics. So they are all hydrocarbons. The bonding for hydrocarbon, they are covalent. So they are covalent bonding. Okay. So what are covalent bonding? So you have C and H in hydrocarbon. So in this one, you have a CH power 4. So you have 4 hydrogens around the carbon. So they are sharing the electron. So when they share, this kind of bonding is called covalent bonding for hydrocarbon. Then you can convert the two electron sharing as one single stroke or one line like that. This one is called single bond. If you see two stroke means double bond and triple bond and so on, right? Okay, so this one you know already. So here you see another type of hydrocarbon, ethylene. So you have double bond, C to C, double bond. And still they are under covalent bonding. Right? You have double covalent bonding. And this one is ethylene. And you have triple bond. Triple bond. And here is carbon. Why hydrogen don't have double bond, triple bond? Why hydrogen you don't see double bond, triple bond? Huh? Why? And you see carbon have a one line, two line, three line. Why hydrogen only have one? Huh? Yeah. What your answer? Yes, not atom, but one electron outside the hydrogen. So how it create more electron cannot, right? So when you draw crystal structure, when you draw the molecular structure, remember hydrogen always have one. Don't go and suka add one line, two line there. Then we will start to question. Do you understand the fundamental of molecule? Okay. So you start to see unsaturated word there. Okay. So previously the one single bond, they are saturated carbon, saturated. And then if you have more than one covalent bonding, they become unsaturated. Okay. Then you see furthermore many types of hydrocarbon. Still you're seeing C, carbon, hydrogen. Okay, so you have same composition but different arrangement. They are called isomerism. So for example, normal butane and isobutane. So you can see butane, normal butane, you have C, 4C, and surrounding by H. If you count the carbon and H molecule, it's still the same. But because of the different arrangement, we give it another name. So for example, the one on the right here, the name is isobutanate. Same number of carbon, but different arrangement. This phenomena is called isomerism, right? Okay. So there's a table for you to refer for CH system. And you can see what is important. I need to highlight here on top of the board, on top of the table here. You see CnH2n plus 2. This is a very important formula for hydrocarbon. Okay, so when you do your revision, copy this one somewhere if you deal with polymer question. Copy this one and put somewhere in your answer so that it remind you that how many carbon you have will link to how many hydrogen you have. You change the N, here also you change. For example, methane, your N is 1. So you put 1 here, you get 4H, you get H4. Okay, same with ethane. You change the C2, the N is 2, so here 2 times 2, 4 plus 2 is 6, you get H6. Okay, so this formula is important. CnH2n plus 2 is important for hydrocarbon analysis later. The boiling point, all this you can refer to graph if this question come up in your final exam, right? So, okay. So if you can, what need to highlight here is that you see the boiling temperature from -164, and you increase the molecular weight or more carbon and more hydrogen, the boiling temperature drop. Not drop lah, but is from minus something to positive value. Okay. Then of course the other types, another table, hydrocarbon, alcohol, R something, ester, acid, and so on. So you'll see a ring shape. Ring shape, it represent all these. If you draw a ring shape, it represent 1, 2, 3, 4, 5, 6, 6 carbon with H, 1, 2, 3, 4, 5, 5H, and then one connecting to other molecule. Okay, so why I need to highlight this one? You know that every time you deal with chemical composition, when you need to calculate mole, right? How many mole of hydrocarbon, then the reaction. So if you see the structures given in the question, you need to convert this into this. If you see question asks you, and you see this one in the question, it gives you a certain crystal structure and then ask you to calculate something. Remember to change this one into this structure. Okay. So R means ring. R means a ring or organic groups. So the two plastics or polymer material, they are very familiar, plastic and elastomer. So how do you differentiate these two polymer? Plastic break into two more, thermoplastic and thermosetting plastics. Again, you need to see the chemical bonding between them. Elastomer or rubber, they are elastically deformed when there's a force applied and can return to its original shapes when the force release. So elastomer means elastic. You able to pull and then you let go, is able to return to its original shape. But plastic cannot. Plastic is, no matter how hard you press, it's still there. So plastic, you have two types, thermoplastic and thermosetting, depend on their bonding. So later we'll go deep into their chemical bonding. Okay. So let's go into thermoplastics and thermoset. So this is plastics. So I give you all the information. I highlight the important one. So thermoplastics, they need heat to form. And then if you need to do a new shape, you just supply more energy, reheat again. And they are covalent, they have a covalent bond. However, for thermoset, it was cured. You need chemical to cure it. Okay, you need chemical to cure it. You cannot remelt. Okay, you cannot remelt the thermoset. So the differences is here. Plastics you can reheat, but thermoset you cannot reheat. Okay. Okay, there are two. Okay. Then the growth of change, the chain growth of your polymer. This one you learn in your chemistry already. So the process is called polymerization. You combine all the monomer together, become a long chain. Okay. So and the bonding here again, we keep repeating the same word, covalent bond. Covalent bond for polymer. Okay. Okay, the first one, we look at ethylene, ethylene C2H4, or you remember the general equation CnH2n plus 2. So this one is 2, ethylene is 2. So again, they are covalently bond, and they are bound by double bonding, double bond. So again, if you are given ethylene, C2H2, sorry, C2H4, CnH2n plus 2. So you have to know how to draw the crystal structure, not crystal, the chemical structure. So C, and then you form. C, you know that carbon you know that have free empty space there, or four atoms outside. So you by default you have two line there. Okay, then you have a hydrogen, you have 4. So the maximum you can pack is 4, but you have 2 carbon. So you need to share the remaining hydrogen. Share the remaining hydrogen, you can only share the maximum 4. So share between 2, break into half. So 2 one side, 2 one side. What happened to another 2? They will combine with carbon. These 2 will combine, you get double bond. Okay, so this is how you build the molecule structure. Okay, so this is a very simple example. Of course, later assessment, you're given a very big molecule. Then you need to guess what are how you build the covalent bonding, whether double bond, triple bond, or single bond, and even I highlight just now the ring structure. Yeah, the ring structure, it look like this. Like this. Okay. Okay. So there are 2 types of notation. If the question asks you to do electron dot, you draw like this. If the question asks you straight line notation, you draw like this. If the question doesn't mention which type, you can do either type. Okay. The way how you arrange your H doesn't matter. We want to see the line, the bonding between the thing. Okay. So once you have more than one bonding, you have 2 double bond here, it fall under unsaturated hydrocarbon. What else? Okay, unsaturated means if you give enough energy, the covalent bond will open up. Okay. So if you're heated, this give energy, the double bond here will break up, and it will open up. It becomes single bond, single covalent bond. Okay, and this one is a free radical. Right, it will grab any particles around the solution, around the element. Right, so there are 2 parking space here. So you're going to grab anything that can match. Okay. Okay, then when you do hydrocarbon, you need to consider the reaction of catalyst and ethylene monomer. So how do you make ethylene? So R is a catalyst or enunciator. Catalyst, you have 1 dot there. So if you add in catalyst, the hydrocarbon, in this case, double bond hydrocarbon, or if you look at crystal structure, this is ethylene. So if you add ethylene and enunciator or catalyst species. This one will open up and join with the share one electron with the enunciator. So double bond will open up to become single bond. Okay. Okay, so when it open up, you share with one, and then there's still one more free, we call it free side or unpaired electron on the another side of the carbon. Okay. Then this free side is going to grab another hydrocarbon. Like for example, this one. So once you add reactor or enunciator, you're going to steal one electron from the carbon. So it will break down the double bond. It becomes single bond, but another side of carbon have free side or free electron. This whole object we're going to go and capture another hydrocarbon. In this case, we're going to capture the ethylene structure that's stable. You're going to steal another, break this double bond, break this one, combine with this one, and there's one more free, we call it a free electron here. So you're going to build the long chain. Going to build very, very long chain until the process stops. Okay. So this is how the polymerization works. We continue to build and build. So at the end, you'll get a repeat unit. So A is the long chain, B is a backbone structure. So this one is a line representation. This is more on the three-dimensional presentation. So for your answer in assessment, you don't need to draw this one. You draw the line one. Okay. Or if you're lazy to write this one, you just can simplify with the bracket and then put an end there. So this is your object lah. So what is repeating here, you put inside here. Okay, so for example, the repeating is C, C, H, 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 the bracket, N at the below. Okay. So here, for example, the ethylene, N bracket, double bond. You heat and add in catalyst. You will break the double bond into single bond, and yeah, it become polymer. Okay, and you have a chain continue. So this is how you write the chemical reaction for polymerization. Okay, so this is an important slides. It is important slides. All right. Okay, the rest I think you're able to understand. It's quite direct. And it's a degree of polymerization. So this one, sometimes you look at the question will let you know what is the degree of polymerization. Right. So if it tell you 2 degree means 2 here, 3 degree means 3, n is 3. Okay. So yeah, so you can either draw in this way or another way also can. Okay, there are many ways of presentation for your polymer. Okay, but basically they are same lah. Actually they're same. Okay, so there's one question come out. We start mathematical calculation already. So if you look at ethylene that go through polymerization process, so the question asks you if a particular type of polyethylene, okay, polyethylene is a C2H4, has a molecule mass of so, what is the degree of polymerization? So it asks you to find the N. So it gives you molecular mass 1500 kilogram or 00 gram mole. So what is the degree? So you calculate lah. So degree of polymerization equal to the molecular mass, or you want to write in the linear also can. This is quite straightforward. dP equal to the big molecule mass divided by individual polymer or mer. Huh? So you will take polymer divided by mer, okay, both in molecular weight. Then you get your dP. Right? So it just tell you that N times your mer equal to the total polymer or total of your polymer. Right? You take how many monomer combined, you get the total chain, right? So this one you refer to molecular weight. Then you rearrange the equation, right? So here, molecular mass you have, right? So molecular mass was given 15000. Individual mole, how you calculate in the individual mole? When you break them, is C, and then H. You're able to count from the periodic table. Carbon is 12, H is 1. So you have 2 carbon means 24 plus 4, 28. Okay. Yeah. Then you do the simple calculation. This one you have 5000 mol per mole. Okay. Yes. Anything wrong? Correct. Okay. Okay. This is the first equation for polymer. Okay. Very straightforward. Also, I consider as a bonus mark question if this one come out. Or we call it no brain question. You don't need to like think very hard now. Okay. Then how the polymerization steps? There are a few steps. I give you all. So you have 3 types. So this is an explanation question. Explain how the polymerization step start. So you have 3 major steps: initialization, propagation, and termination. They must have a starting point, and then the process happen. Propagate means it continue to break the chain, and then it stop. So these 3 words is important. You don't use other your layman words. So if you being asked to explain what is the chain reaction or chain polymerization steps, you need to mention initialization, you need to mention propagation, you need to mention termination. Okay. Okay. So how initialization steps? You start with okay. Let's say okay, this is another example. So this is hydrogen peroxide. Is a catalyst. So you need a radical, you need a catalyst to start the process. So if you use a hydrogen peroxide with its H2O2, H2O2, okay, H2O2, you know that H is 1, oxygen you have 2. So what you want to do here is you supply heat, you break the chain for the oxygen. Okay, why you cannot break the hydrogen bond? Hydrogen bond is very, very strong, because you only have one electron, and you want to break the hydrogen and oxygen is very hard compared to the covalent bonding. So you break the double bond, you get free radical. So free radical here, as you can see, hydrogen miss one electron. So you're going to grab anything that have extra electron. In this case, you are deal with hydrocarbon. Hydrocarbon, you know that earlier you exposed to carbon. When you break carbon, carbon always lack of always have one extra electron. So electron are going to carbon are going to combine with this radical. Okay, so Here, hydrogen peroxide heat, you get free radical that you form 2H and then single bond and O and then the dot free electron. So again, in your answer, if you have a free radical, for example, oxygen, remember to include the one dot there to represent as a free radical. Okay. And then what else? Other organic peroxide beside hydrogen peroxide. As long as you have peroxide, something peroxide, then you have OO at the center and then other things. The R here is other ring, either it's a ring or something. Then you will get free radical also. So if you mix radical, if you mix catalyst, this is like left hand side catalyst. Catalyst, they always have one free electron outside. Sometimes there are two, sometimes three, but in this case, we have we just use a very simple example that have one free electron, and then you go to ethylene hydrocarbon that's stable with double bond or maybe sometimes triple bond. So what this free radical do? He going to steal one of the electron from the hydrocarbon, in this case ethylene. So the double bond breakup, you will share with O, so it will become R dash O dash C, but another second carbon here will have one free electron there. Remember to include this small dot in your answer. Don't miss out this one. Okay. So this one is called in this initialization stage. Okay. Initialization stage means you consider the catalyst, right? Then propagate. Propagate means you continue to join with other hydrocarbon. So you can see here, the left-hand side, this one is the enunciator. They already initiate already. So initiate, what is the initiation stage? Product is something with a small dot there, plus the stable polymer. But the polymer, you know, they are covalent bonding. So they are unsaturated. So we want to change unsaturated into saturated polymer. So we break the bonding of the double bond, then we will make a very long change of hydrocarbon with a single dot at the last element there. Okay, so this is called propagation. Propagation means you add more monomer inside there until the last stage called termination. Okay, what is different is that double bond switch to single bond. But again, propagation equation, the last one should have one free electron. If you don't, electron means stop already. The process stop already. Okay. Termination. How you terminate? You add free radicals or two chains combined, right? So this one is possible when there's an impurity that inside the solution. For example, this chemical reaction. So you have polymerization. This bracket M means you already have a chain there. Right here, this is a M, free radical, and then you combine with the very long one. What is the difference between the left equation and right equation? The dot combined with other. Okay, this one combined with other, and then this dot will become combined with radical. Yeah, so this is another table that explain about polymerization. Okay. How you apply this table when it comes to your exam, maybe test 2 or your final exam, you'll be given the name of that particular polymer. Then it asks you to write, explain the polymerization process or calculate the degree of polymerization. This one. Okay. Again, pay attention to equation that you learn. If there's any equation, that is the area that we can access your understanding. So if we deal with equation, then pay attention to it. Graph, of course, phase diagram, you cannot run away. And again, phase diagram inside there only have one level rules. So make sure you know. And then the earlier one is a percentage of weight of mass. That one. Okay. Right. So this is an illustration from extract from YouTube. Maybe help you to more you can visualize the process. This is ethylene, C2H4. This propagation. Okay, so this is how you get the polymerization process. Okay, I think 2 more slides, then we stop. Thermoplastics. So how you get the average molecular weight for thermoplastics? You take the average weights for thermoplastics divided by the weight fraction multiplied by individual molecule divided by the fraction. So M divided by sum of Fm divided by F. It's like you finding the center of gravity or center of mass, the Y bar thing. Same principle. A degree of polymerization also can written in the chain size, where you take the average molecular weight divided by the molecular weight, like what you calculate just now. Okay. Okay. So we apply this one in one of the example by this one. Okay, so you're given a chart, a table. We ask you to practice or how to calculate the average molecular weight for this set of thermoplastic. So because when you conduct experiment and you create polymer in the chemical lab, there is an average that you will see under the instruments. A certain molecular weight, how many you have, right? Then you need to do some calculation. You are given the molecular fraction, Fi, for molecular weight range between the table. You need to find, for this type of a polymer, what is the average molecular weight. So you're given range and then Fi. So how do you build? You need to change this table into this table. Because you need to use the equation m equal to sum of Fm divided by F. Right? So you need M, Fi, Fim. It's like you're doing your statistics, your statistics class. Same principle. So what else? Okay, so Fi was given. So what you do, you find the average of molecular of or all the range. How you find average? Maximum, minimum, divide 2. Cross divide by 2, you get average. Fm you copy from the table. Then you do products. First row multiply by second row, you get the Fm. Okay, this value multiply this one, you get this one. Then after that, you get the sum of Fi, sum of Fim. You take this one divided by this one, you get the average. Fi given in the question. It must give you something. Fi must give. If not give, you cannot do it. Okay. Okay. Then you apply the equation. Fm equal to this one divided by this one. Then you get the average molecular weight for this set of thermoplastics material. Okay. Why we get this range of molecule in the instruments? Because of the three process: initiation, propagation, and termination. Because inside the solution, maybe some still at initialization, some still at propagation, some already terminate. So that's why you have this range for polymer. Okay. Okay, I think we stop at example 1. Next lecture, we continue with the same question.